Today we're going to work on Unit 1. This is going to be solving linear equations. This comes from Chapter 7 in the book. Um, some key vocabulary that we want to mention again are these words here: variable, coefficient, term, like terms, and unlike terms. When you leave this class, hopefully these are some of the words that you still would know and are able to help other people with these terms that may not have had algebra. So variable is going to be a letter that represents an unknown until it's given an identity. So typically we're talking about the letters of the alphabet. So we're talking like, X is probably the most common, but it could be like Y or even like the ABCs. So X is going to be X until I tell you what X represents. So it's what, you may see the word vary in the word variable. So these letters can vary from, question to question, depending on how they're defined. The next word is the word coefficient. The coefficient is the number in front of a variable, and it's going to be connected by multiplication. So like if I give you 2x, 2 is the coefficient, and x is the variable, and 2x means 2 times x, or as we said, x plus x. Or if I gave you negative 5y, negative 5 is the coefficient, and the y is the variable, and that would mean like 5 negative y's. You could also have like fractions or decimals, so you could have like 2a over 7, where 2/7 is actually the coefficient and a is the variable. So this last one, a lot of times, like I said, it really should look like 2/7a, but a lot of times instead of putting the coefficient out to the side, they may put it actually in the numerator, but they kind of mean the same thing. So a term is a number, a variable, or product of numbers and variables. Everything is connected by multiplication. So that's a key thing about a term. So a term could be a number. So like my favorite number is, of course, the number 2. It could be a variable. So it could be x, or it can be products of numbers and variables. So again, we could have, say, 3y, or we could even have them using exponents. So we could even say like, 5m squared, since everything is connected by multiplication. Like terms have the same variables with the same exponents. The coefficients do not have to be the same though. So for like terms, if I give you 3x and 4x, notice how the variable part is the same. The coefficients do not have to be the same. So these are considered like terms. So if I have negative, 3y squared, and I have, say, negative, or say 4y squared, notice how they have the same variable raised to the same exponent. So these will be considered like terms. Unlike terms, the variable is not the same. So if I give you 3x and 3y, even though the coefficients are the same, the variables are not the same. So we would describe these as like terms. I'm sorry, these would be unlike terms. So as we move into solving equations, I do want to review adding and subtracting in algebra, positive and negative numbers. In algebra, it's easier to say combine like terms when addition or subtraction are present. So keep that in mind. Combine like terms, combine kind of means to add like terms. So in working with positive and negative numbers, there's 2 basic rules. Adding same signs, what we do there is we add the numbers and keep the sign. In other words, we think like income and debt. So if I have a negative 8 plus a negative 2, this is going to equal negative 10, because notice how they both have a negative. You have a negative 8 and you have a negative 2. So that would represent, adding 8 and 2 and keeping the sign negative. We also can think of this in terms of debt. You have negative 8 could mean $8 debt. Plus kind of means combine, and we're combining it with $2 debt, which results in $10 debt. So notice if I give you negative 7 plus then negative 4, we would describe this as a negative 11. Like signs, just add the numbers together and keep the sign. adding different signs. So adding different signs, basically what we do is we subtract the two numbers and keep the sign of the larger number. So if I have a -10 and a 3, so notice how the signs are different. So essentially what we're doing is subtracting the 10 and the 7, which gives us 10 and the 3, which gives us 7. And since it's more negative, it stays negative. Well, if I give you 10 plus -3, notice how it's more positive than it is negative. Therefore, answer is going to be a +7. So when you subtract, you got to pay attention to which sign is larger. So when it comes to combining like terms, what I like to use is what's called the circle strategy to identify terms. So when using a circle, what's inside the circle is always going to be added together. So when I do this, 4m, what I do is I circle the first term. When I circle the 2, I also include the operation with it. So that means that's a +2. And then when I circle the last term, notice I include the subtraction sign in there. So the terms are, in this problem here, 4m would be the first term, 2 or +2 would be the second term, and -3n would be the third term. So if I have 2x minus 4, if I'm talking about terms, the first term is the 2x, and the second term is a -4. So those would be what we call the terms. So 2x is the first term, and the -4 would be the second term. Notice how I use that word "and." That kind of is starting to imply combining like terms. So when I am combining like terms, if I have 3x plus 4x, remember 3x means 3x is added together. And you're combining it with 4 more x's. So notice that we have 1, 2, 3, 4, 5, 6. There's 7 x's here added together. Since we have 7 x's added together, we can also write that as 7x, because 7x means 7 x's added together. So the shortcut to this is when combining like terms, recognize that what makes these like terms are the x's. So notice how this has an x and this has an x. So they have like terms. If they are like terms, all you really have to do is add the coefficients and keep the variable. So mathematically, what we're doing in our head is we're adding just the 3 and the 4, and we're keeping the x on the end. And therefore, this turns into 7x, like so. So if I want to simplify -8x minus y minus 3y plus 2x, using the circle method, identify the terms: 8x, a -y, a -3y, and a 2x. So notice that the -8x and the +2x are like terms, so they can be combined together. So if I add the coefficients, that's going to be -8 plus 2. Since the signs are different, that actually tells me to subtract. So 8 minus 2 is 6, and I have to keep the sign of the larger number, which would be the -8. So it's going to end up being then this -6. So it's going to be -6x. So when I'm going to go about, combining the -y and the -3y, when I'm combining those together, remember that the coefficient of the -y is actually a -1y. So again, if you're talking about coefficients, there's a -1 and a -3. So it's going to give me a -4y. So we write this as just -4y, which kind of means -4y. So in algebra, we usually don't write this as -6x plus -4y, even though that's correct. More commonly, we just write this as -6x minus 4y. It just requires fewer symbols. So even though this says subtraction, when I'm talking algebra, I'm looking at it as terms, and that would be a -6x and a -4y. So I kind of read it like this. It's interchangeable. So again, coefficients can be confusing. As I said, typically it's the number multiplied in front of the variable. It can be anything. Most commonly, though, it's going to be a number. So notice how, again, we have 2a over 11. Really, the coefficient is actually the fraction 2/11, and the a is actually the variable, like that. So everything is connected by multiplication. The number in front is actually the 2/11, which is actually a fraction. So as we move into your section, you're going to probably see coefficients that are actually our fractions. As we move into algebra, we start to use what's called the distributive property. The distributive property is when we multiply through addition. So there's this multiplication through addition. So what this looks like then is, notice I have this 3, and then in parentheses, I have this 2 plus 5. If I'm using the order of operations, we would do what's inside the parentheses first and say, hey, this is 3 times 7, which is 21. So that's not distributive property. That's order of operations. Distributive property is when you actually multiply the 3 through the addition. So this turns into 3 times 2 plus 3 times 5. So this turns into 6 plus 15, which turns into 21. So when you multiply through the addition, that's described as the distributive property. So when I want to multiply this 3 times this quantity, x plus 4, quantity kind of means you use parentheses. So when I have this quantity, x plus 4 here, notice that x plus 4 are not like terms. So they cannot be put together. So to remove the parentheses, what we do is we use the distributive property. We multiply through the parentheses. In doing so, the parentheses are removed. So 3 times x is going to give me 3x. And then 3 times a positive 4 is a positive 12. So we would put down plus 12. So it turns into this expression here, 3x plus 12. Another thing you may come across in this class here is subtraction. It gets confusing. So one of the things we pick up on is with subtraction, when there's an expression with parentheses behind the subtraction symbol, what we can do is we can distribute the negative through the parentheses. When you distribute a negative through the parentheses, what happens is there's this changing of signs. So what I'm looking at is when I see this expression 7 minus this quantity 5x minus 4, this whole thing actually has to stay together for the time being. And the 7 stays by itself here. What we actually do is we actually bring the negative through the parentheses first. So remember, order of operations, we want to remove parentheses. The only way to remove these parentheses, though, is this negative sign here has to go through there. And what it's going to do, it's actually going to take the opposite of what's in the parentheses. So this becomes then a negative 5x. And notice how this is a negative 4. It's going to turn into a positive 4. So now we have this 7 minus this 5x plus 4. Notice how the 7 and 4 are like terms. So I can actually put those together and write this as 11. And then you have this negative 5x or minus 5x, if you will. So that's how that would actually be simplified. Excuse me. So another thing we want to talk about is multiplying positive and negative numbers. In algebra, the left side reads as negative 5, then the equal sign is equivalent to. The right-hand side actually represents the opposite of 5. These two sides are interchangeable. When it comes to multiplication, it's actually easier to look at it from this perspective. So when I have a negative 5 times a 3, what we actually do is we pull the negative out and call it the opposite of 5 times 3, since those are interchangeable. So what we actually do is multiply the 5 times the 3 and then come back and take the opposite of 15, which turns into a negative 15. So if I have a negative 4 times a negative 3, notice how we actually change this to the opposite of a 4. And then instead of multiplying by negative 3, we say the opposite of a 3. So in other words, we're allowed to separate it with the negatives out in front and the 4 times the 3. So notice how 4 times 3 is going to give me 12, but I got to take the opposite twice. So the opposite of a 12 is a negative 12, but then the opposite of a negative 12 turns into a positive 12. So a negative 4 times a negative 3 is actually a positive 12. So what we kind of do is this. When multiplying positive negative numbers, we kind of think like a light switch. The negative will switch the answer back and forth from negative to positive. So if I have a negative 2 times a 3 times a negative 5, what we're really doing is multiplying 2 times 3, which is 6. 6 times 5 is 30. So we put that down. And then we think light switch. So one negative makes it negative. The second negative makes it positive. But that third negative flips it back to a negative. So therefore, the answer is a negative 30. And that's how we would be multiplying positive and negative numbers is think like a light switch. This just kind of goes back and forth between a positive or negative. So when it comes to solving linear equations, if the exponent is 1, the degree of the equation is considered a linear equation. So notice how if I have x plus 4 equals 9, notice how the exponent of the x is a 1. So since the exponent of x is a 1, this is a linear equation. So if I have x plus 4 is equal to 9, notice how there's a left side of the equation and there's a right side of the equation. So the right side of the equation is clearly 9. So what I'm looking for is the value of x that makes the left side the same value as the right side. And we will see that that's a 5. So 5 is going to be called the solution. So we have this word solution. The solution is the value of the variable, in this case, the value of the x, that makes each side the same value. So as we move into algebra, a strategy to solve more complicated equations is what's called the property of equality. So the property of equality kind of says if you perform an operation on one side, you must perform that same operation on the other side to keep the equation balanced, if you will. So if I have this equation, x minus 7 is equal to negative 9, if I want to use the property of equality, I can try to get x by itself. So what we kind of pick up on is there's this negative 7 here. The negative 7 is also called the constant. What we want to do is add its opposite, because what happens is if you add its opposite, it will zero out. In other words, it will actually cancel out of the problem. So if we have a negative 7, 7 would actually be called its opposite, and negative 7 and 7 would be called what we call a zero pair. So that's actually a zero pair. So notice how I have this negative 7 there. I can add a 7 here as long as I add a 7 over here. By doing so, the negative 7 and the 7 zero out, and that leaves me with my x. And then negative 9 plus 7 is actually going to be a negative 2. Since the signs are different, we want to subtract. 9 minus 7 is 2. But since it's more negative, there's more debt, if you will. I have to remain in debt. I have to remain negative. So if I have the equation 3x minus 5 equals 15, to get x by itself, what I need to do is make the coefficient to be 1. Notice how the coefficient right now is a 3. To make a coefficient of 1, what you do is you use the division property. If you divide an expression, if you divide the coefficient by itself, it will make a 1. So if I divide the left side by 3, to keep it equivalent, I have to divide the right side by 3. So that's how the 3 and the 3 will divide out. That leaves me a 1x. Instead of putting 1x there, that just gives us x. And negative 15 divided by 3, notice that 3 does go into 15 5 times. And since there's one negative, that will keep it negative. So negative 5 times 3 does give me negative 15. That does check out. So the negative 5 here would be called the solution to this equation. So the next thing we have going on here is we have this 3/5 x minus 4 is equal to 12. Again, to get x by itself, the first thing we actually do is go after the constant. So we go after the negative 4. To go after the negative 4, we use its opposite, which would be a positive 4. But if I add a 4 on this left side of the equation, I have to add 4 on the right-hand side of the equation to keep it balanced. So this will give me this 3/5 x equals then this 16. So again, to solve for x, I'm going to rewrite this now. 3/5 x equals 16. What I got to do is divide each side by the coefficient of 3/5. So if I divide this side by 3/5, I have to divide this side by 3/5. Now, that looks a little weird. So instead of using a fraction bar as a division symbol, I can also write this as 16 divided by 3/5. So one way to do this is what we call Kentucky chicken fry, or this stands for keep, change, flip. Keep, change, flip. So if I want to do a division problem, we keep the 16. We change the division symbol to multiplication, and we have to flip the 3/5 to being 5/3. So now if we multiply straight across, we end up with this 16 times 5. 16 times 5 would be 80. So this would be like 80/3 as an answer. So x would equal then this 80/3. We would leave it as a fraction unless they ask us to do otherwise. Now, again, you can also do this on a calculator. So if I come over here, see if I can pull up my calculator. Didn't get myself prepared for this, so let me give myself a second here. So again, I'm somewhere else. So remember to get out of this. There's this quit button above the mode. So if the second button, hit the mode button, it'll get me out. I can clear this out here. So if I go 16 divided by, and again, I can use the alpha button for the fraction mode, alpha y equals, and I can choose number 1, and I could put in divided by 3/5, hit enter, and that'll give me 80/3. And notice that when it does it on the calculator, it also puts it in lowest terms. So usually on my lab math, they usually like to leave this as just a improper fraction numerator denominator, unless the directions specify differently. So we would get 80/3 either way we do that. So that would be our solution. So again, we got rid of the constant to start with, that -4, and then we got rid of the coefficient by dividing by the coefficient. So these are some basic steps to solving more complicated equations. So the first step will always be to simplify each side of the equation. This is going to be about removing parentheses. This is also going to be referred to as the distributive property. And then combine it like terms would be the other thing. If the variable is on both sides, what I like to do is pick on the little guy. And again, I like to use like what we call the zero pair. We want to add the opposite, basically, is what that means. So from there, we want to make the constant 0 using zero pair. And then we want to make the coefficient to make that equal to 1. By doing so, we should have had, that means x should be by itself at that point. Now, there could be this thing that happens where the variable drops out of the equation. If the remaining equation is true, then the solution is described as all real numbers. If the remaining equation is false, then the solution is described as no solution, empty set, if you will. So empty set is sometimes we use this notation here. So if I want to solve the following equations, let's look at this equation: 3x plus 8x equals 44. The first step is look at each side of the equation. So if I look at the left side, I see 3x plus 8x. Well, those are like terms. So if I add the coefficients, 3 plus 8, that gives me 11x. And then the 44 is already simplified. At this point, all I really see is a coefficient in front of the x. So to make that coefficient equal to 1, we just divide by the coefficient. We divide by 11. So the 11s would actually divide out over here and just give me 1x, or we just call that x. And 44 divided by 11 would just be 4. So x equals 4 would be the solution. And sometimes in my lab math, they may write this, the solution of 4. They may use this notation as a way to express that answer. So if I have a 3a minus 8 equals 7a, notice how the left side is simplified. 3a and -8 are not like terms, so I can't combine those together. And 7a is simplified, so the left and right side are simplified. So from there, the next step is to pick on the little guy. So what I'm looking at here is the 3a and the 7a, and I'm asking myself, who would be considered littler? What I'm referring to there is the smaller coefficient. So 3a is the littler coefficient. So what I want to do is zero out the 3a, so I use its opposite. So I put a -3a here, as long as I put a -3a over there. You can also say 3a minus 3a. So that's just going to zero out. That leaves me a -8. You can also say, you can say 7 plus -3, or you can say 7 minus 3. And that's going to give me this 4a. So again, like terms, you focus on the coefficients. So a 4 and a -3. Notice now we just got to get rid of the coefficient of 4 in front of the a. And to do that, we just divide by the coefficient. So I divide each side by 4, and that allows me to get the a by itself. So -8 divided by 4 would be a -2. So a would equal a -2. As the solution set, we also could write that as a -2, like that. So if we look at this equation here, 8 minus r equals 76. A strategy I like to use on this is, since this is a fraction, I can make 1 a fraction by putting it 1 over 1. So remember how we said if you have a fraction equal to a fraction, the cross products have to be equal. So I actually can cross multiply here and make this work this way. So when you multiply 8 minus r by 1, nothing changes. that stays as 8 minus r. And when I multiply 76 times 1, that just turns into 76. Now the coefficient and the constant, notice how the coefficient here would actually be would be a 1 here, a negative 1, if you will. So the constant is actually the 8. So I want to go after the 8 to start with by using a negative 8 there, as long as I put a negative 8 over here. So the 8 and the negative 8 will zero out, and that'll leave me with like a negative 1r. And 76 take away 8 would be, what would that be? So 66, 68. Yeah, looks like 68. 68 and 8 would be 76. So then to make the coefficient a positive 1, I have to divide each side by negative 1. And so r is going to equal, again, negative 1 divided by negative 1 will divide out. In other words, that becomes a 1r, or r. And 68 divided by 1 is still 68, but that negative makes it a negative 68. So therefore, our solution is going to be negative 68. So if I have negative x equals 7, this looks pretty easy. But notice how there is a coefficient of a negative 1 there. So if we divide both sides by negative 1, that allows me to get x equals then this negative 7, if we want to follow that approach. So the next equation I have is negative 3/4 y equals 5/8. Notice how we're starting to dabble a little with some fractions here. So what I can do is just divide each side by this negative 3/4. But if I divide this side by negative 3/4, I have to divide this side by negative 3/4. So what I have then is y equals, and using my calculator, I can divide 5 by negative 3/4. So if you use my alpha button, so I have then negative 3/4. And that's going to give me negative 20/3. Let's see if I can get this working here. So negative 20/3 would be my solution. So my solution state would be negative 20/3. So keep in mind, you could also go 5 divided by negative 3/4 like this, and we can call it Kentucky chicken fry, keep, change, flip. So this becomes 5 times negative 4/3. And then 5 times negative 4 would be negative 20. And then the 3 would just come down since there's nothing to knock it out with. So we have that going on. So if I have x plus 1/7 x equals 16, one thing I can pick up on here is since we have the property of equality going on, what I could do is multiply each side by the 7, which is the denominator. So if I multiply this side by 7, I have to multiply their side by 7. By doing so, this now creates distributive property. So I have to bring the 7 through here and remove the parentheses. So 7 times x is going to be 7x. The reason I put that 7 there is it's going to divide out with the 7 on the bottom. So notice how that 7 and that 7 are going to divide out. So we kind of pick up on that. This 7 and this 7 are going to cancel out. This is going to turn into 1. And then I'll bring that 1 through to a 1. 1 times 1 is still going to be 1x. So I would have just 7x plus 1x over here. Then I have the 16 times 7. So 16 times 7 would be, what's that, 42. 7 would be 112. This is going to be 112. And then also the left side, we still have to simplify because we have like terms. This turns into 8x equals 112. So again, I have to divide each side by an 8. So I have to divide 112 by an 8. So 8 would go on 11. Those at one time. That'd be 32. 8 go on 32 4 times. So that'd be 14. So x equals 14. So again, you could use your calculator and divide 112 by 8. Or you could actually even use reducing of fractions. So if you have this 112 over 8, you could also recognize that there's a common divisor of a 2 there. So half of 112 would be like, was it 56? And half of 8 would be 4. Half of 56 would be like, what is that? 28. Half of 4 would be 2. And then 28 divided by 2 would actually be 14. So you could also just use the concept of dividing out a common factor of 2 each time and reduce it down to 14 that way. So if I have the expression -3 times x plus 8 equals -39, notice how to simplify this, we have to bring the -3 through the parentheses. So -3 times x is going to be -3x. -3 times 8 is going to be a -24, so I just put down -24 there. That still represents a -24. And then this -39 comes down on the right-hand side. So from here, we want to go after the constant, which is the -24. So if I add a 24 to this side, I have to add a 24 to this side. So it's going to now give me this -3x. And then I have to figure out, well, what is -29 plus 24? Notice how that's subtraction. That's 39. Take away 24. That's going to be 15. But notice how it's more negative, so it's going to be a -15. So if we're using a calculator, again, we had, notice how right next to the enter key is the negative symbol. There's -39 plus 24. I can put that into the calculator like that, hit enter, and that'll give you the answer of -15. On this calculator, you cannot interchange the negative symbol with the minus symbol. So if you get an error, what that means is you probably accidentally hit the subtraction symbol instead of the negative symbol. So just keep that in mind. Those are not interchangeable on your graphing calculator. So now I got this -15. Now to get rid of the coefficient of a -3, I can divide both sides by -3. So we have x equals, and then we know that 15 divided by 3 is going to be 5, and a negative divided by negative is going to just be a positive. So that's like that like switch. One negative is negative, two negatives makes it back to a positive. Or again, using your calculator, you can type a -15 using that negative symbol, divided by a -3, hit enter, and that would give you your +5. So that would be your solution. 5 would be the only number that would satisfy that equation. So if I have 2.3x equals 4.6, notice I can multiply each side of the equation by 10. By doing so, that will actually make the decimal slide one place to the right. So this becomes 23x equals 46. Now, if I divide both sides by the coefficient, divide by 23, divide by 23, we get x equals, looks like 2 23s would be 46. So 2 would be my solution to that problem. Of course, you could just divide 4.6 by 2.3 using your calculator. So if you wanted to, you didn't have to remove decimals. You can just go 4.3 divided by 2.6 and let the calculator worry about it. And that's would still give you, did I type that in wrong? 4.6 divided by 2.3. All right, try to get that backwards, didn't I? So 4.6 divided by 2.3. That looks better. So that does give me 2 as a solution. So another thing we're going to get into is what we call application problems. So in applications, we need to figure out a strategy to do this. So I'm going to try to walk you through some of the problem-solving strategies working with word problems. So horticulturist marks off a 32-meter wide rectangular nursery plot with 158 meters of fencing. Because the plant's supposed to be properly spaced, she needs to know the length of the plot. So find the length in meters. So what we're looking for is usually the unknown fact. So the unknown fact is going to be the length in meters. So I can let, x is going to be the equals the length in meters. So we're talking about the rectangular plot. So the known facts is we see, 32-meter wide rectangular nursery. So we pick up on that, the width is going to be 32 meters. So I'm just going to write down 32 there. And there's 158 meters of fencing. So 158 meters of fencing. So I kind of got my known facts width and then the 158 meters of fencing. So from there, we need to identify a relationship. Well, this is kind of a geometry question because there's this word rectangular. So in drawing this, we pick up on that there is this rectangle going on. And we know that the 32 goes here, which means there's also got to be a 32 over here. What we don't know is the length in meters and the length in meters. But the fencing has to go all the way around the rectangle. So the relationship I'm picking up on is, a lot of times the word perimeter comes into play when we're talking about going around an object. So the four sides of the rectangle must add up to the fencing of the 158. So what I'm picking up on is there's this 32 plus this 32 plus this x plus this x must equal this 158. So notice that, I could use estimation here, and, I could say, well, 158 is close to 60. 32 and 32, is like, that's like 60. It looks like I need 100 meters, but that 100 meters has got to be shared on two sides. So what I'm looking for as an estimation, it looks like 50 would be what I'm looking for as an answer. So that would be, to me, the estimation is just kind of using some rounding. So once we have 160 there, so again, if I'm kind of drawing my drawing here, so we know that if each side is 30, that adds up to 60. And that leaves us with 100 to be shared on each side of a 50 and a 50. So 50 and 50 and 30 and 30 does add up to 160. So the answer's got to be close to 50 for the length using estimation as a strategy. So as we do calculations, what I can pick up on is there is a formula here that says, 2 times the length plus 2 times the width is equal to the perimeter. Notice how we have two 32s, two widths. Notice how we have two lengths, 2L equals this perimeter, which is 158. So notice how we used X to represent the length. So that's going to be 2X. Notice how the width was 32. So I can say two 32s like that. And the perimeter is going to be 158. So this becomes then 2X equals, 2X plus 64 is equal to this 158. So then, to solve this equation for X, we have to lose the 64. So we got rid of the constant by putting a negative 64 here and a negative 64 there. In other words, subtracting it. So I'm gonna let the calculator do that. 158 take away 64. That's gonna give me 94. So I'm gonna have 2X equals 94. And then to get rid of the coefficient, I have to divide each side by 2. So I have to divide 94 by 2. So 94 divided by 2, we'll let the calculator do that as well. That's going to give me 47. So X equals 47. So my interpretation would be then, the length is going to be then 47 meters. That would be my interpretation. So that means that, 47 plus 47 plus 32 plus 32 should add up to this 158 if I want to double check my work here. So, 2 times 32, two 32s plus two 47s. That should add up to then 158, and it does. So that would make this problem solved. Let's look at another example of a word problem. So machine part weighs 2.7 kilograms and is shipped in a carton weighing X kilograms. If the total weight of 3 packaged machine parts is 9.3 kilograms, how much does each carton weigh? So notice how we have 3 parts and 3 cartons drawn here. So the only thing we know for sure is what's given. Let's see. Again, the unknown facts again is it's always what they're asking for. Notice how it says how much does each carton weigh. So the unknown fact is the weight of 1 carton. And notice how, based on the diagram, they're using X to represent the weight of a carton. That's going to be the unknown. That's where a variable comes in. The known facts is the 2.7 is going to be the weight of the part. And we do know that we're going to have 3 parts. And we're going to have overall the 9.3 represents 3 parts. The 9.3 kilograms represents the 3 parts and the 3 cartons, the weight of all that. So that's kind of what we know. So the relationships we're picking up on is, we got this total weight of 9.3. That means like we have this, 2.7 plus 2.7 plus 2.7. There's going to be like 3 2.7s. Plus, we're going to have this these 3 cartons. So it's going to be like 3 cartons. That's got to equal the total weight of 9.3. That's the kind of relationship I'm picking up on. If I'm using an estimation, what I'm seeing is, 3 times 2.7 is close to 3 plus 3x, and 9.3 is close to 9. So what I'm picking up on then is, 3 times 3 is 0, plus 3x is equal to, 3 times 3 is 9, plus 3x equals 9. So if I subtract 9 on each side, I get 3x is equal to 0. If I divide each side by 3, I'm getting x is equal to 0. So I know the answer's got to be pretty close to 0 based on that math. So let's see if we can play this out here. So 3 times 2.7 would be my calculations. 3 times 2.7. That's going to give me 8.1. So this is going to be 8.1 plus 3x is equal to 9.3. I can subtract 8.1 to both sides, or add a -1 to negative 8.1 to both sides to get the constant out of the way. So 9.3 take away 8.1, that looks like 1.2. So 3x equals 1.2. If I divide each side by 3, x is going to equal then, so it's 1.2 divided by 3. That's going to give me 0.4. So 0.4. So our interpretation is each box is going to weigh 0.4 kilograms. So that's going to be the weight of the carton. Now, kilogram is basically like the weight of a textbook. So kilograms kind of a lot of weight. So, 0.4 is close to, 0.5 or half of a kilogram. So if you tore up, half of a textbook, if you will, that's going to be the weight of a carton. That starts to make a little bit more sense. So as we move into the final phase of this, we got a few more problems to work out. If I want to solve equations, one of the things we can do is remove fractions from an equation. I was already kind of doing that in an earlier question. Just want to do another one. Notice how there is a fraction in this equation. So again, if I want to multiply by the common denominator, which is a 4, what that's going to do is that's going to eliminate fractions out of the problem. So if I multiply each side by the least common denominator, well, since there's only one denominator, it's 4. So when I do this, though, I got to bring the 4 through each piece. So 4 times x becomes then this 4x. 4 times 1/4, again, the 4s are going to divide out here and turn into a 1. And then 1 times x, 1 times 1x is going to still just be 1x. And then on the right-hand side, 4 times 8 is going to be 32. So by using the property of equality, my equation looks totally different, but it's still a true statement. So 4x plus 1x is now going to give me 5x equals 32. If I divide each side by 5, that's going to give me 32 over 5. So let me fix that there. So 32/5 would be the solution to that equation. So if I'm looking at 2p plus 2/7 p plus 1 equals 1/3 p, notice how my denominators are the 7 and the 3. So thinking, multiples, it's going to be like 3, 6, 9, 7, 14, 21. It looks like if I keep going, 12, 15, 18, 21 is going to be the least common denominator. So if I want to knock out the 7 and the 3 at the same time, what I can do is, instead of just multiplying by 7 and then come back multiplying by 3, I can actually multiply each side by 21 and do it all at once. So notice how, again, I'm going to start with the denominator. 7 goes into 21 3 times, and then 3 times 2p is going to be 6p. And then 21 times 1 is going to be a 21. So again, I'm going to start the denominator. 3 goes into 21 7 times. 7 times 1p is going to be 7p. So I can write this equation as 6p plus 21 equals 7p. Notice how, again, I can get rid of the 6p because it's the little guy. Subtract 6p over here, or add a negative 6p if you will. Add a negative 6p over there. The 6p and the negative 6p will zero out, and we have 21 equals then 1p. Notice how the coefficient is a 1, so we're kind of done. P is equal to 21. So again, 21 would be the solution. Lost my parenthesis there. There we go. So if I look at this equation here, this application, so find the total resistance in a parallel DC circuit with 3 branches rating at 4 ohms, 10 ohms, 20 ohms, respectively. So to solve this, we have this equation given to us: 1 over R equals 1 over 4 plus 1 over 10 plus 1 over 20. So the formula, if it's a parallel circuit, to find total resistance, it's going to be 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So in other words, you add those together. So they've already created the equation for us. So we have this 1 over R, and what we want to do is we have this 1/4 plus this 1/10. So we have this 1/10, and we have this 1/20. So what they're wanting us to do here is they want us to multiply each side by the least common denominator. So there's a 4, a 10, and a 20. Well, the first multiple of 4 would be 4, then we'd have like 8, 12, 16, and 20. We'd have 10 and 20 and then 20. So it looks like 20 would be the least common denominator. So our approach to this is actually multiply this all side by 20, as long as I multiply all this side by 20. Now, Ken, you could have used a calculator and added those fractions together, but so what I have now is this 20. Oops, I actually even have an R present. So I actually need to multiply by 20 and an R, because the R is also in the denominator. So let me clean that up a little bit. Lost that R there. So R is also in the denominator. So we have, again, got this 1 over R. So we actually even have an R. So our LCD is actually going to be 20 and an R. So the 20 with respect to the numbers, and then the R there. So I'm going to multiply this side by a 20R. And I'm going to multiply this side by a 20R. So when we do that, the R is going to cancel out over here. So it's going to leave me my 20. So R divided by R is going to divide out and leave me 20. Here, I'm going to have 4 goes in 20 5 times. It's going to become then 5R here. And then I move over to the 10. 10 goes in 20 twice, so that's 2R times 1 is 2R. And then the 20s will divide out. R times 1 is going to be 1R. So if I add my like terms together, 5R, 2R, and 1R is going to be 8R. So 20 is going to equal this 8R. So now to get rid of that coefficient, I can divide both sides by an 8. And I could reduce that fraction by dividing the numerator and denominator both by a 4. So that's going to give me like 5 halves. So the total resistance is going to be 5 halves. So that's going to be 5 halves ohms. So that would be our solution to this problem. So to find interest paid on a loan is another question we may come across here. So this is what's referred to as simple interest. In simple interest, the I equals PRT is the formula that we're going to be using. So I represents the interest you're going to either be receiving or owing. So interest received or owed. So if you borrow, that's what you have to pay back. If you're investing, that's what you're going to receive. The P is going to stand for the initial amount invested or borrowed. R is typically, it's going to be a yearly interest rate. So it's going to be a percent. And then T is going to be the time in years that the money was invested or borrowed. So notice how it said find interest paid on a loan. So notice how we're borrowing money. So this is something that we're going to have to pay back. So if we borrow $800, what we want to figure out is how much we have to pay back with interest as well. So we don't know what the interest is. That's going to be the unknown fact. That's going to be unknown. But the principal is the amount that was initially borrowed in this case. So the principal is going to be actually the 800. The rate is going to be the 8.5%. Remember, this has got to be a decimal, or so it's not a bad idea to change this to 8.5%. But remember, we still got to move the decimal 2 places to the left. That's going to be actually 0.085 because our calculator doesn't do percents. So we need to go ahead and divide 8.5 by 100 or change it to 8.5 and move the decimal 2 places to the left. Because remember, percent means dividing by 100. The time was the 2 years. So what I can do is say I equals then the 800. A lot of times I'll use parentheses here for multiplication. 800 times then the rate was this 0.085. And then my time was 2 years. So using my calculator, I can multiply that out. 800 times 0.085 times 2. I'm not going to use parentheses on my calculator. I'm just going to type that straight in. That gives me 136. So if I borrow $800 at 8.5% interest for 2 years, I'm going to have to pay back, what was that again? $136. So 136 is going to be interest paid on the loan. So I would have to pay back the $800 and the $136 in order to be square with my borrowing. So the interest is all they ask for, though, which is $136. Okay. So notice that you can leave the labels out while you do the math, and then you can stick the labels back in. So there's 2 trains of thought. Leave the labels in, take the labels out. It just depends on the situation. I think here it's easier to just leave the labels out and just go straight for it and then stick the label back in. So that concludes solving linear equations and also working with some applications in chapter 7.